Dear viewers, today I am going to show the advanced PMSM drives developed by National-Infotech. So first we have see the scalar control mode of PMSM. So first we have given the protection. Okay, so you can see on the display first protection we have given the DC link voltage. Okay, so here first we can set the DC link voltage to 300. Then if it is reached to 300 volt, then it will display will update. Okay, so in the protection we have set the 150 volt. So when 150 volt is reached, DC link voltage is reached to 150, then this display will update. So in this protection, one more thing is, once you can set the 150 volt, then it will update the display. Then if once 150 volt is reached, then another time, second time, if you can decrease the load to 0, means voltage to 0, then you have again increase the voltage to 150 volt, and then you can start the control, then it will not start. Okay, so first time if you can increase the control DC link voltage to 150 volt, then you can start it, then your algorithm will be run. At the same time, if you can decrease the voltage to 140, then again you can increase the 150, then it will not work. Okay, so this protection will be added here. So now we have start the increasing the DC voltage to 300 volt, and you can see the display. Okay, so first we can reset the controller. Okay, so you can see once my DC link voltage is reached to 150, this display will update. Okay, and you can see now we have set the DC link voltage to 314 volt. Okay, then you can see the display will update here. Okay, so this is the direction status of the controller. 0 means off, 1 means on, direction 0 means anti-clockwise, 1 means clockwise. Okay, DAC 1 value, DAC 2 value, set speed, reference speed, actual speed, ID and IQ. Okay, so you can connect the inverter like this: positive rail. Okay, all positive rail you can short, all negative rail you can short it. Here you can connect the motor. Okay, so here motor terminal you can connect here from inverter output. Okay, then you can short these 3 links. Okay, one encoder wire you can connect here. Okay, so here you can connect the P9 wire. Okay, PA9 wire, earth wire. Okay, so this is the earth wire. Okay, just a wait. Okay, so this is the earth wire you can connect here. Okay, 5 volt from this connector. Okay, so it will connect here 5 volt and ground. So 5 volt you can take from here. Okay, 15 volt for the encoder you can take from here. Okay, so this is the 15 volt and this is the ground. Okay, so encoder input is 15 volt, ground PE9 PA9. Okay, and earth. Okay, then one more thing is gate pulses. So here you can connect the 6 gate pulses. Okay, so 6 gate pulses you can connect here. Okay, and ground and 5 volt you can connect here. Okay, all the gate pulses you can connect here, and from here the AC DC sensor out. So this is the 3 AC current sensor. So I, U, V and W current sensor, ground, VDC sensor and the ground. Okay, so here you can connect at the input of this here I, U, V, W and VDC, and here first pin you can connect the reference speed port. Okay, and here you can connect the ground, both grounds. Okay, and here you can see the DAC pins. So from here you can observe the DAC values. Okay, so now function wise switch. Okay, so you can see the function is by pressing K5 you can start the controller. Okay, you can start the control. By pressing this K3 you can change the direction. By pressing this key you can apply the reference speed. Okay, By pressing K1 you can change the DAC1 value. By pressing K2 you can check the deck 2 value. Okay, and once you can press the K5 button, PD1 LED will be indication. Okay, on, and by pressing K3 LED, 3 means PD10 LED will indication, give the indication. K5 means speed apply. So once you can press the K4 button, then PD2 LED will be indication. Okay, so now you can see, we will start. We have applied the uh, DC link voltage. So when we can start the controller, first it will align the rotor, then after it will start the working. Okay, so first we can start it. Okay, so once it is aligned the rotor, then it will start the rotating. Okay, soft start we have applied, so it will start the rotating. Now you can see, initially it will set the reference actual speed to reference speed set to 750. Okay, then after you can set the your reference speed by wearing this port. Okay, so at this time I have set the reference speed to 2000 rpm. Okay, then you can see when control is start, this LED will be indication. Okay, then when I want to apply the speed, reference speed 2000, then you can press the K4 button. So you can see when speed is applied, then this LED will be indication. Okay, and you can see the reference speed is achieved at the actual speed. Okay, so you can see. Okay, so reference speed and actual speed is achieved. Okay, now I am increasing the reference speed to 3000 rpm. Okay, so now you can see our reference speed is and actual speed is 3000 rpm. Okay, so and you can see the voltage and current waveform. Okay, VA command and the IA current. Okay, and by pressing these buttons you can change the deck values. So you can see here I'm changing the deck values. Okay, so likewise this you can check the all deck values. Okay, now I have stopped this control, so it is running in anti-clockwise direction. Okay, now we have applied the another direction. Okay, so once it will reach to 0, then you can press this button, so it will indication will show on the PD 10 LED, and you can see the direction is now 1. Okay, now you can start the control, and you can see converter is 1. So it will rotate at the clockwise direction. It is reached to 3000 rpm. Okay, now you can see it is reached to 3000 rpm and it is working perfectly. Then you can see the voltage and current. So PMSM motor is working in the scalar control mode, so you do not apply the loading. Okay, so now we have removed the applied speed, so it will settle to minimum speed we have set. Okay, so you can see when I am pressing this button, it will set to minimum speed. Okay, so likewise this you can test the PMSM motor in the scalar control mode. Thank you.